The Curiosity rover is a robotic spacecraft mission operated by NASA as part of the Mars Science Laboratory (MSL) mission. It was launched on November 26, 2011, and it landed on Mars on August 6, 2012. The primary goal of the Curiosity mission is to explore and investigate the Martian climate and geology, assess whether Mars ever had environmental conditions suitable for microbial life, and study the planet's potential for human habitation in the future. Here are some key details and notable explorations of the Curiosity rover. Size and capabilities. The Curiosity rover is much larger than its predecessors, weighing about 2,260 pounds, 1,025 kilograms. It is approximately the size of a small car, standing at about 7 feet, 2.2 meters, tall. Its size allowed it to carry a more extensive payload of scientific instruments compared to previous missions. Scientific instruments. Curiosity is equipped with 10 science instruments, including cameras, spectrometers, radiation detectors, environmental sensors, and rock vaporizing laser called the CheemCam. These instruments allow the rover to analyze the composition of rocks, soil, and the Martian atmosphere. Gale Crater landing site. The rover landed in Gale Crater, a 96-mile wide, 154 kilometers, impact basin on Mars. The crater's central mountain, Mount Sharp, Ylus Mons, is Curiosity's primary target for exploration. Exploration of Mount Sharp. Over the years, Curiosity has been climbing the lower slopes of Mount Sharp, which is believed to be a layered mountain with deposits of sediments that can provide valuable insights into the planet's geological history. By studying these layers, scientists hope to uncover clues about past environmental conditions on Mars. Evidence of past water. One of the most significant findings by Curiosity is the presence of ancient stream beds and lake deposits in Gale Crater. These discoveries provided strong evidence that Mars once had flowing water and a potentially habitable environment in its distant past. Organic compounds. Curiosity detected organic compounds in Martian rocks, including methane fluctuations in the atmosphere. While the origin of these compounds is still being investigated, their presence indicates the possibility of past or even present microbial life on Mars. Radiation measurements. The rover has been measuring the Martian surface's radiation levels to assess the potential hazards for future human missions to the planet. Longevity. The Curiosity rover's original mission duration was planned for 2 years, but it has far surpassed this expectation. The Curiosity rover is a remarkable piece of engineering designed to explore the Martian surface. It possesses specific physical properties and has been meticulously constructed to endure harsh conditions of space travel and the challenging environment on Mars. However, like any complex project, the construction of the Curiosity rover also faced various challenges. Here are some details on the rover's physical properties and construction challenges. Physical properties. Size and weight. The Curiosity rover is significantly larger and heavier than previous Mars rovers. It stands about 7 feet, 2.2 meters, tall, measures approximately 10 feet, 3 meters, long from its arm to the rear wheels, and weighs around 2,260 pounds, 1,025 kilograms. Power source. Curiosity is powered by a radioisotope thermoelectric generator, RTG, which converts the heat from the natural decay of radioactive isotopes into electricity. This power source allows the rover to operate for an extended duration without relying on solar panels. Mobility. The rover's 6 wheels are individually actuated, giving it excellent mobility on the uneven and rocky Martian terrain. It can drive at a speed of up to 0.09 miles per hour, 0.14 kilometers per hour, and is capable of maneuvering around obstacles. Scientific instruments. Curiosity is equipped with 10 sophisticated scientific instruments, including cameras, spectrometers, a laser, and various sensors, enabling it to study the geology, atmosphere, and potential habitability of Mars. Construction challenges. Building and assembling a rover as large and complex as Curiosity was a significant challenge for engineers and scientists. It required precise design, intricate fabrication, and thorough testing to ensure all the instruments and systems would function correctly in the extreme Martian environment. Entry, descent, and landing, EDL, the landing sequence, known as the 7 minutes of terror, was one of the most critical and challenging phases of the mission. Getting a rover of Curiosity's size safely to the Martian surface required the use of a novel sky crane descent system, which involved a parachute, retro-rockets, and a lowering mechanism to gently place the rover on the ground. Communication. Establishing reliable communication between Earth and Mars is a significant challenge due to the vast distances and the atmospheric conditions. The construction of communication systems capable of transmitting data between the two planets with minimal delay was a crucial aspect of the rover's design. Radiation protection. Mars' thin atmosphere provides less protection from cosmic and solar radiation compared to Earth. Designing the rover with adequate radiation shielding for its sensitive instruments and electronic components was essential to ensure their functionality during the mission. Despite these challenges, the construction and successful deployment of the Curiosity rover have been monumental achievements in space exploration. The rover's longevity and numerous scientific discoveries have significantly expanded our knowledge of Mars and its potential for hosting life in the past. The experiences gained from Curiosity's construction and mission have also paved the way for future Mars missions, including the Perseverance rover, to continue the quest for answers about the Red Planet. For the latest updates and findings, I recommend checking the official NASA Mars Science Laboratory website or other reputable sources for current information.